Hello everyone, so we're moving on to chapter 8, electricity now, and I have changed these notes, so make sure you've got the most updated notes. So going to start off by looking at static electricity, and before we start that I just want to talk about subatomic particles. So hopefully you've heard of these particles before. All matter contains atoms which are made up of electrons, protons, and neutrons. Okay, so I put a negative sign above electrons and a positive sign above protons and a zero above neutrons. That's because protons and electrons are electrically charged particles and neutrons are neutrally charged, no charge. So electrons are negatively charged and protons are positively charged. And the easiest way to remember that is pro and positive, and then you're pretty much right. So the important thing to understand is that opposite charges will experience an attraction force towards each other, and like charges will experience a repulsion force away from each other. Okay, so this is called the electrostatic force and electrostatic attraction and repulsion. So if we have an electron here and a proton here, then they will experience a force attracting them towards each other. If you have two protons, then they're going to repel, and if you have two electrons, they are also going to repel away from each other. So static electricity. So an object having a negative charge has an excess of electrons. It can still have protons, it just has a greater number of electrons. Similarly, an object with a positive charge has more protons than electrons. Okay? Static electricity is a result of transferring charges from one object to another, usually through friction, creating an excess of electrons or protons on the surface of an object. You may have experienced an electric shock after walking over a carpet. This is because the friction between yourself and the floor has caused a transfer of charged particles, usually electrons, and the shock is the dissipation or balancing of that charge. Okay, so basically what's happening is that some objects are more attractive towards electrons than others, and then that the transfer of electrons creates an unbalanced charge, but things want to be neutral. So things tend to be electrically neutral, and so what happens is a dissipation or a balancing of that charge to make them neutral. So one of the pieces of equipment that you often see in physics classrooms is a Van de Graaff generator, and it looks like I've got a diagram below. It looks like this. Now, let me see if I can zoom out. So, what we have here, and there are plenty of videos online to see if you don't get a chance to see one firsthand. But what we have here is a rubber belt. So let's see what they say here. They got good. Yeah, we got the explanations here. So we have the side of the belt. So what we have here is a rubber belt, and it's going upwards and downwards. So it's just going around these rollers, and we have rollers of different materials, and they will be, and they create friction, which creates a separation of charge. And so what we have here is positive charges on the outside of the belt, and negative charges on the inside of the belt. And those positive charges get collected by a comb here, and then they get collected on the surface of this sphere around here. They get collected around the sphere, okay, and they are on the surface of the sphere. And then we have our negative charges being connected to this sphere up here. And what happens is we call it a difference in potential energy. So there's a difference in energy, and that energy wants to be dissipated. And we've got this lightning strike here that is the dissipation of energy. So you get little sparks happening between this sphere and this sphere, and that is the same principle as lightning coming from the sky as well. So a difference in charge and a difference in energy create and it needs to be dissipated across those two. So let's have a look. Let's just read through these notes then. So a Van de Graaff generator, see diagram below, provides a fun demonstration of a build-up of charge. The friction between the rubber belt and a roller, such as acrylic, causes a separation of charge so that the sphere of the generator and anything touching the sphere has a positive charge. The positively charged sphere is in a higher energy state, and the dissipation of this energy requires an object which can absorb it. The Earth is a classic example of an object which can absorb electrical energy, and therefore the release of the electric potential is often referred to as going to ground. So you might have heard that term before, going to ground, or a grounding wire. In actuality, a large metallic frame, such as a satellite in space or the frame of a car, can act like a ground if it is large enough to compare to the electric potential, and there should not be an 8 there, so I'll delete that. Okay, so in some demonstrations, a teacher may touch the Van de Graaff generator, and then their hair will stand on end. You've probably seen it before. So why does that happen? And that's because anything connected. Oops, I'm going to zoom in so I can write properly. I'll just undo that last bit so I can write a bit more neatly. So anything connected to the Van de Graaff generator becomes positively charged, and then the charged here, will want, and therefore anything that's positively charged will want to be repelled. So then the positive charge will repel each other. And it just doesn't happen to hair as well. So another example of this is putting, say, tin foil, like pie tins on there, or just tin foil on top of the Van de Graaff generator, and then they will all start to fly off as the electrostatic force builds up enough to overcome gravity, essentially. Okay. So basically, they are the forces acting on it, so gravity and the electrostatic forces. So once those repulsion forces are big enough, then the hair will stand on end. So where does all the charge come from? Where does it finally go? So the separation of charge comes from the friction. Friction of the belt on the roller. And then the charge is dissipated. Ooh. Not responding, running too quickly for it. Then the charge is dissipated to the grounding sphere. Okay, so what's happening when a spark jumps between the Van de Graaff generator and the earthing rod? Okay, so what's happening here is that when there is sufficient charge, so when the charge is large enough, the energy is large enough. Oops, large enough. You don't need a T at the end. Oops. Large enough, but is large enough to jump the gap by ionizing the air. So another name for charge is ion. Ion. And so the air particles. So what happens is that the charge is big enough that electrons are actually able to flow through the air. And this is the exact same principle as lightning, which we'll look at in the next video. Yeah. Okay. So here's our Van de Graaff generator, and the next one is we're looking at the elementary charge. So we'll leave our video there.